Hello and welcome to MP Maths. Today we're going to look at indices and in particular we're going to focus on the GCSE syllabus. Many of the rules still apply to A-level, so if you are taking your A-levels and want to have a recap and a refresh of indices, then please do watch this video. So what we're going to do is go through the key rules that you need to know for your GCSE maths exam. And then we're going to attempt a few questions from a past paper. So, if we start with the rules, there are a number of rules that you need to know for the exam. So we're going to take each one in turn, and what I encourage you to do is to go away and learn these rules and apply them to various different questions from your past papers. Right, so if we take these in turn, the first rule then is the multiplication rule. So, rule 1, if we have a to the power of m times a to the power of n, that would equal to a to the power of m plus n. And the rule here is essentially when you have a base, in this case it's a, and you raise it to a power, and you're multiplying that by the same base, so a again, to another power, all you need to do is add the powers together. That's the first rule. So second rule, if we have a to the power of m, and we're dividing now, so not multiplying, but dividing a to the power of n, then instead of adding the powers, all you do is you subtract the powers. So you have a to the power of m minus n. So that's the second rule. Third rule then, if you have a to the power of m in brackets, and you raise all of that to the power of p, what you get is a to the power of m times by p. So the rule here is if you have a base to a power and raise that to a power in brackets, and you're raising that whole thing to another power, you multiply the two powers. So here you're multiplying the m and the p to give you mp. The next rule, so this one is really just something to remember, but we're still going to call it a rule. If we have a to the power of 0, then what you get is an answer of 1. So this rule basically states that if you raise anything, any number, to the power of 0, your resulting answer is 1. Right, so now it gets a little bit more difficult, but these are, again, just rules that you need to remember. So number 5, if you have a to the power of minus n, so now you're raising a base, here the base is a, and you're raising it to a negative power. And what happens is you get an answer which is 1 over a to the power of n. So this rule basically states that when you're raising a base to a negative power, you end up with the reciprocal. So the way I like to think of this is the difference between having an a to the power of n and the a to the power of minus n is that when you calculate a to the power of minus n, it's just the reciprocal of a to the power of n. So a to the power of minus n is 1 over a to the n. By raising something to the negative power, all you're doing is taking the reciprocal, meaning 1 over. Okay, so if we move on to the next rule then, if we have a to the power of 1 over n. Now this is basically saying if we raise a base to a fraction, what happens here? Well, what we do here is, first I'll tell you the answer. So the answer here is the nth root of a. Now the rule is this: when you're raising a base to the power of 1 over something, the answer is going to be the root of the base, but in this case it's the nth root of the base because we are raising the base to the power of 1 over n. So because it's over n, we take the nth root. So I'll give you an example. If the question was 8 to the power of a third. So in this case, a is 8 and your n is 3. Our answer here would be the nth root of a. So in this case, n is 3, so it would be the cube root, and your a is 8, the cube root of 8, and that is 2. So that's the rule. Right, so if we move on, and we look at what happens when we raise the base to a negative fraction. So in this case, let's say we had a to the power of minus 1 over n. Then what happens here is, essentially what we're doing is we're combining two rules. So remember, we said when you raise the base a to the power of 1 over n, your answer becomes the nth root of a. So the nth root of a. Now, remember, we're not just raising this to the power of 1 over n, but we're raising it to the power of minus 1 over n. And what did we say earlier? We said when we raise the base to a negative power, we take the reciprocal. So what the answer here is going to become 1 over the nth root of a. Essentially what we've done is we've combined two rules together here. So that's rule 6. Essentially it's just a combination of two earlier rules that we've already gone through. The next one then is if we raise the base, so we'll call this rule 7. So if we raise the base a to the power of m over n, so now it's not a to the power of 1 over n, but it's a to the power of m over n. Then again, this is a combination of two rules. One of the rules that we've already been through, which is because it's over n, we know that in the answer we're going to have the nth root of a. However, now we've introduced something else here. What does the top of the fraction do? When you raise the base to the power, when you raise the base to a fraction, the top of the fraction here is essentially where you raise the answer to that particular power. So in this case, we're going to raise the answer, so the nth root of a, the whole thing, we're going to raise that to the power of m. So if we take an example, if the question was 27 to the power of 2/3, then we can see that the bottom of the fraction in the power is 3, so we're going to take the root, so the cube root of that, and then we're going to raise the whole answer by the top of the fraction in the power, which is the 2, so we're going to square the whole thing then. So what we have is the cube root of 27, and we raise that whole thing by 2. And that would give us an answer, so the cube root of 27 is 3, and 3 squared is 9. So your answer there would be 9. Right, so finally, if you had 27 to the power of minus 2/3, then we know, like earlier, we know how to work out 27 to the power of 2/3, and we also know what happens when you raise a base, here's the base 27, to a negative number. Essentially, you take the reciprocal. So 27 to the power of 2/3, so which is, we said, the bottom of the fraction is 3, so you're going to take the cube root of the base, which is 27. You're going to raise the whole answer by the top of the fraction in the power, which is 2. And then, because you've got a negative power, you're going to take 1 over that, or you're going to take the reciprocal. So what is 1 over the cube root of 27 squared? Well, we know that the cube root of 27 is 3, 3 squared is 9, so your answer is 1 over 9. So those are your 8 rules, essentially, that you need to know and be comfortable with, so that you can apply them to questions in the exam. So let's have a go together then. If we look here, this is question 10 of an exam paper, or a GCSE exam paper, and these are the kind of questions you could get in your exam. So we'll do these together. So the first one says 3 to the power of minus 2. So we said earlier in our rules that when you raise a base, so the base here is 3, and we're raising it to a negative power, then in your answer you're going to take just the reciprocal of that. So what's 3 squared? Well, 3 squared is 9, and the reciprocal of 9 is 1 over 9. So that's your answer. Part 2 then, 36 to the power of a half. So we said that when you raise a base to the power of a fraction, here it's 1 over. What do? Well, we take the root, so the root of 36. In this case, it's going to be square root because the bottom of the fraction here is 2. So that's the square root of 36. And we raise this by the power of the top of the fraction. The top of the fraction is 1. So root 36 to the power of 1, which is the same thing as root 36, which equals to 6. And that's why you find when you have questions where you have a base and you raise it to the power of 1 over something, we just tend to take the root. We don't then raise it to the power of 1, because raising something to the power of 1 doesn't change that answer. So if we look at part 3 then, in this case it's 27 to the power of 2/3. So now we're raising the base to the power of a fraction, but in the fraction it's not 1 over something, but it's 2 over something. So when we raise the answer to that particular power, in this case going to be 2, that will change our answer. So 27 to the power of 2/3, but we know the bottom of the fraction in the power is 3, so we're going to take the cube root of the base, which is 27, and we're going to raise the whole answer by 2, because that's the top of the fraction in the power. So the cube root of 27, as earlier we said, is 3. 3 squared then is 9, so your answer is 9. Finally then, we have 16 over 81 to the power of minus 3 over 4. Right, so we have 16 over 81, that's our base, and we are raising that to a negative power. So we know the negative in that power means that we're going to end up taking the reciprocal. So let's ignore that for now. We're going to raise the 16 over 81 by 3 over 4. So the bottom of the fraction is 4, so we know we're going to take the 4th root of the base, which is 16 over 81, and then we're going to raise that whole answer, or whatever the answer to that is, to the power of the top of the fraction, which is in the power, which is 3. So what's the 4th root of 16? Well, the 4th root of 16 is 2, because 2 times 2 times 2 times 2 is 16. So that equals 2 over, and the 4th root of 81 is 3, because 3 times 3 is 9, times 3 is 27, times 3 is 81. So that's 2/3, and we're raising that, so the whole 2/3 to the power of 3. So what's 2 cubed? Well, 2 cubed is 8. 3 cubed is 27. So you've got 2/3 cubed, which is 8 over 27. Now, the final step then, remember we're raising this to the negative power, so we need to take the reciprocal of 8 over 27, i.e. 1 over 8 over 27, and the simplest way of doing that is just to flip it over. So 1 over 8 over 27 is the same thing as 27 over 8. So you could just go straight from 8 over 27 to 27 over 8 by just flipping that fraction or turning it over on its head.